Welcome back. This is an Aleks homework video on calculating the pH of a buffer. Okay, do you remember what a buffer is? A buffer is a mixture of an acid with its conjugate base, or a base with its conjugate acid. And what happens is that the buffer regulates the pH and keeps it within a very narrow range. There's lots of buffers. Your blood has buffers to keep your blood within a certain pH. It happens all the time. And this is actually quite easy as long as you know that in order to do a pH with something that you already know the acid or dissociation constant, the Ka, or even the Kb, you need an equation. You need the Henderson-Hasselbalch equation relates the pH to the K sub A. So there's two forms of it. You can, if you have an acid, then the pH is going to be your pKa. Now remember, your Ka, in order to find the pKa, you're going to take the negative log of that number. So in this case, I've got 6.3 times 10 to the negative 5. It'd be the negative log of that. That's the pKa, times the log base 10 of your conjugate base divided by the molarity of the acid that you started with. That would be for an acid. If you're given a base, it's not that hard. You're just basically relating it to the K sub A again. So the pKa plus pKb equals the pKw. Remember, that's the water constant, and that's always going to be a 14. So pKa plus pKb equals 14. So pKa equals 14 minus your B, okay, minus your pKb. So if you're given a base, just tweak that. All you're doing is turning that pKa into what you know instead of having to find the acid for it. So the rest is quite simple. You're just going to fill it in. So I took the negative log of my K sub A, found 4.2 something, and then made a fraction out of my molarity, because they gave you the two molarities, the molarity of the conjugate base and the molarity of the acid, and then took two decimal places at the end to find the pH. So scary question, but really easy if you know that there's an equation for this. Okay, hope it helps.